Hello and welcome to this video brought to you by Smart Exam Resources. In today's video, I shall explain to you the oxidation of primary alcohols. So let us begin. There are two different kinds of oxidation that I shall be explaining. One is the partial oxidation and then is the complete oxidation. So what happens in partial oxidation? So in partial oxidation, the alcohols are converted to aldehydes. So this I shall explain with the help of an example. So as you can see, there is a reaction that is shown, and we know that all alcohols have the functional group OH. So I'm going to circle the OH group. So we have seen that ethanol is getting changed into ethanol, which is an aldehyde. And we know that ethanol is an aldehyde because it has the presence of CHO functional group. And when ethanol is getting changed into ethanol, that is when an alcohol is getting changed into an aldehyde, it is under the presence of acidified dichromate ions and heat. So this is the condition required for this kind of oxidation. And this oxidation is called as partial oxidation. So whenever an alcohol gets changed into an aldehyde, the oxidation is called as partial oxidation. Now here I'm using the example of dichromate ions, acidified dichromate ions. But I shall tell you something important about this oxidation process. So something that will actually help you in your further studies. Okay. Now, going back to the, excuse me. Okay, going back to the second kind of oxidation, that is the complete oxidation. It says that in complete oxidation, the aldehydes are converted to carboxylic acids. So we just saw that the alcohol got changed into an aldehyde, and now the aldehyde is getting changed into a carboxylic acid. So when the oxidation continues from aldehyde to carboxylic acid, it is called as complete oxidation. So what has happened? The process has got completed. The alcohol first got oxidized partially into an aldehyde, then it got changed into a carboxylic acid. When carboxylic acid is formed, we call this oxidation as complete oxidation. And again, I'll show you the same example here. So what is happening here? Once again, I'll circle and I'll show it to you. So this alcohol represented by the OH group is getting changed into an aldehyde represented by the CHO group, and then the aldehyde is getting changed into carboxylic acid represented by the functional group C double bond O single bond OH. So COOH is the functional group for the acid, carboxylic acid. So when the oxidation results in the formation of a carboxylic acid, we call it as complete oxidation. Once again, we see that the same acidified dichromate ions and heat are being used. So this is all we can say about the partial oxidation and the complete oxidation. Now I show you the balance equation for the reaction. So here is the balanced equation for the reaction. It shows OH getting changed into CHO functional group. That is the alcohol getting changed into the aldehyde functional group, and the oxygen written in the bracket indicates that this particular oxygen has come from the oxidizing agent. And in the next step, the aldehyde represented by the functional group CHO is getting oxidized to a carboxylic acid. And we know it's a carboxylic acid because we can see the functional group COOH present in the carboxylic acid. So everywhere you see an oxygen atom written in a bracket, so that indicates that the oxygen has come from the oxidizing agent. Okay. So this is all about the types of oxidation and the equation and the balancing, etc., etc. Now there are a few things I need to add to this explanation. Now Whenever you want to simply get only the aldehyde in this from this reaction, you need to see that this reaction stops at this aldehyde. It should not continue further, and it should not completely oxidize the ethanol into the ethanoic acid. So how do you stop this? Well, as you can see in both the reactions, dichromate, the acidified dichromate ions are being used, but acidified dichromate. So, for example, acidified potassium dichromate is a very strong oxidizing agent. And if you're going to use that in this process, then definitely the reaction will stop only when ethanoic acid is formed because it has a strong tendency, it's a strong oxidizing agent. So, it is going to oxidize completely. So, if you want to manufacture an aldehyde, say an ethanol. So what you need to do is you need to use a mild oxidizing agent and not a very strong oxidizing agent because a mild oxidizing agent will let you control the entire process. Okay, you can stop the process when aldehyde is created, aldehyde is formed, but you cannot stop it so easily. So the process becomes very complex if you use a very strong oxidizing agent which contains these dichromate ions like potassium dichromate ions, etc. Okay, that is one thing is very important you need to remember because these can be a part of your structured questions, of course. Also, I would like to tell you something important here, and that is the H plus ions are needed along with the dichromate ions. This is to become because when H plus ions are present along with the dichromate ions, the oxidizing agent is activated and it becomes an effective oxidizing agent. And in acidic conditions, it gets reduced from orange to green. That is, the Cr6 plus ions get reduced to Cr3 plus ions, enabling oxidation of the alcohol. So, these H plus ions help the dichromate ions become an effective oxidizing agent. Okay. And what did I tell you just now? That in acidic conditions, they get reduced from Cr6 plus to Cr3 plus, that is from orange to green, enabling oxidation of the alcohol. And the oxidation of ethanol to ethanol or ethanoic acid involves loss of hydrogen. Acidic medium helps facilitate this redox reaction. So this tells you why the H plus ions are also needed along with the dichromate ions. So primary alcohols don't always get fully oxidized. Whether they become aldehydes or carboxylic acids depend on the type of oxidizing agent that you're using in the process. And this is an important concept for A-level organic chemistry students because it's frequently assessed in both your structured and MCQ style papers. Also remember the color change and the specific conditions like the presence of heat and presence of acidified dichromate ions required for the oxidation to occur. So this is all in today's video. And if you like watching my video, do not forget to subscribe to our channel in order to receive regular updates. Thank you so much. God bless and take care.